Okay, so we're going to try and solve a few problems from chapter 5 now. And I'm going to try and do something different today. So if you guys have seen any videos from Khan Academy, what you see is they go with a black background with a light colored ink. So what I'm going to try and do today is I'm going to try and write on a black background, and what I'm going to ask you guys to do is let me know if this is better, because I've been reading a few articles and they tend to think that when you're looking at online lectures, a dark background with a light ink gives you better visibility, get greater readability. So just let me know if this is better or not, and if it is, I'm going to stick to black backgrounds in the future. If not, I'll go back to the white background. So the problem we're going to solve from chapter 5 is number 2 and number 3. So let's start with number 2 right here. So we have a consumption function, pretty standard consumption function. And what we have to do is find the equilibrium output. Okay, so that's pretty straightforward. So this is given to us. C is equals to C naught plus C1 y minus t. Of course, what we know is that z equals to c plus I plus g, and equilibrium condition requires y equals to z. So what we can write as a result is that y is equal to c plus I plus g. And c, we can break it down into c naught plus c1 y minus c1 t plus I plus g. As a result, what we get is y equals to 1 by 1 minus c1 by c naught minus c1t plus I plus g. And if we break it down, this is the multiplier, and this is the autonomous part. So we've done exactly this problem in the last chapter. So hopefully all of you would have been able to do this even without my help. That was part A. Actually, what is the value of multiplier for a change in autonomous spending? Okay, so we have identified the multiplier, which is this. In the next part, what we are going to do is we're going to assume that investment is no longer exogenous. So therefore, the level of investment now depends on the level of income and the level of interest rate. So once we relax the assumption that investment is fixed, it's exogenous, let's see what happens. So what we have is, okay, so this is part B. If I equals to, how much was it? B naught plus B1y minus B2y. So before we start solving the problem, let's look at what this means. B naught is the autonomous part of investment. It means that regardless of how much the income is, regardless of how much the interest rate is, this is how much investment we're going to have in the account. On top of that, as our income starts to go up, our investment is going to go up as well, because see, there's a plus sign. So if B1 equals to 0.2, suppose, and our income goes up by 5,000. So 20% of 5,000 is 1,000. So if income goes up by 5,000, investment will go up by And this tells us that as interest rate goes up, investment falls. And we have talked about this before. Remember this I equals to I, yi, and the relationship was that this was positive and this was negative. So we've seen exactly this equation before. Now what we're going to have to do is take this equation and plug it into our equilibrium condition. If we do that, I think this is going to turn into a bit of a messy calculation, but let's see. C naught minus C1t plus I. I is B naught plus B1y B2i plus G. Okay, straightforward so far. But now see what we have. We want y here, but we have y on the right hand side of the equation. So what we are going to have to do is take this y on this side. Okay, if we do that, what do we get? Y equals to, okay, 1 minus C1 C naught minus C1t plus B naught minus B plus G plus what we have here is B2 1 minus C1 y. Okay, so we take this part here, and that will give us y minus b2 1 minus cy equals to 1 minus c, what we have inside the bracket. So this becomes 1 minus c, 1 minus y equals to 1 minus c, what we have in here. And so if we simplify, we get y equals to 1 by 1 minus c. Was it just c? This was c1. Sorry, c1 minus b2. That's whatever we had inside there. And so once again, this is the multiplier, and this is the autonomous case. Actually, let me write down the entire thing. So what we have in here is C naught minus C1t plus B naught minus B2i plus G. This entire thing is the autonomous part. So let's see what the question wanted. Solve the equilibrium output, interpret interest rate. What is the effect of change? Okay, so the first part was for us to find the equilibrium output, which is this. We have done that. Now the next part is for us to explain what is happening. Okay. So let's see what's different. In the initial case, the first case, our multiplier was 1 divided by 1 minus C1. Now our multiplier is 1 divided by 1 minus C1 minus B2, which is bigger. This is bigger because we have added B2 here, which is in the denominator, and we're subtracting something from the denominator. So it's just basic maths. If you subtract or reduce the denominator, the whole value goes up. So what has happened is that the multiplier has become bigger. And so the question might be, why might that be so? So basically, remember once again, what the multiplier shows us is that if uh, if we spend 100 taka, what will be the impact on the economy? So suppose over here the multiplier was 2, but over here it's 2.5. So why is a rise in autonomous part of the demand more uh, having a greater effect on the economy now? And the question, once again, you have to think about it, is that the one thing we have changed is right here. So we have endogenized the investment. By endogenizing the investment, what we have done is now we've made sure that as our income is going up, a part of our income is invested. Initially, investment was fixed. Regardless of what was happening to our income, investment was fixed, but now it's no longer fixed. So let me just give you guys a numerical example that might help. So I'll go back to the example I have used last week. So so what we have is C1 of 0.5, which means whenever we make an income, we save 50% and then we spend the other 50%. So the first person spends 100 taka. This 100 taka goes to someone else. He saves 50% and he spends the other 50. This 50 goes to the third person who saves 50% but spend the other 50, and so on. And if we add all of this up, what we are going to see is that the rise in Y is 200. But now that investment is no longer fixed, so we have B2. So suppose B2 is 0.25, which means whenever our income go up, we invest 25% of it. Now let's see what happens to Y. So the first person spends 100 taka. No changes here. This goes to person 2. Now person 2, what is he going to do? His C1 is 0.5, so he is going to spend 50. But B2 is also 0.25, which means he is going to invest 25. And then he's going to save the remaining 25. So he ends up, in this stage, Y ends up increasing 75. This rise in income of 75 is a rise in income of someone else. And for that person, what does he do? He spends 50% of it and he invests 25% of it. So how much is 25% of this? 18.75. And then so on and so forth. So you see, what we have effectively done is by endogenizing the investment, we've made sure that out of however much income you make, you're going to save less. And not that you're going to save less and consume more, you're going to save less and invest more. And when you invest more, why go up? And if you add all of this up, I think if my calculation is not wrong, you're going to see that this is 400. And so that is effectively what we are seeing over here, is that because our multiplier is larger, I mean, notice that this were just examples that I wrote down, but because the multiplier is larger, the effect of change in consumption or change in income or change in government spending or change in taxation basically everything that's in the autonomous part is now going to have a much larger effect on the economic. Okay, let's move on to part C. Is suppose the central bank choose an interest rate of I, solve for equilibrium output in that interest rate. Okay, so this is a bit of a tricky part. If I'm going to say this straight away, is to solve this problem, remember what we had seen is that in the traditional method, the LM curve looks like this, but then we did a more modern method where LM curve looked like this. Now, to solve this problem, we have to use this, an upward sloping LM curve. And I can already tell you guys that I'm not really going to ask you any question like this in the exam. So if some of you wants to skip this part, that's fine. But I think it's still interesting for us to see how we would solve this problem in the traditional method. So in the traditional method, what we see is that, let me write this down. This is the real money supply, which is equal to, suppose, D1 Y minus D2 I. Okay. Now D1, D2 are just simple coefficients. So think of them as numbers. Suppose we have 3y minus 6i. So it doesn't matter what they are, but we have an I here and y here, and this is basically the LM relationship. I think this equation is also given in question number 3. Let's see. Yes, so see in question number 3, right here, that relationship is given. This is the equilibrium in the money market. So we're just going to use this for now. And so what we are told in question number 2 is that the government has set an interest rate of I. Okay. So what can we do from here? From this equation, let us find the value of I, which is D1 by D2 times Y minus 1 by D2 times M by P. And this is the I that the government has decided to set. Because remember, when we looked at even this LM, we said that the government will hold interest rate as constant. But you can't just decide that interest rate is going to be, let's say, 5% and just let it stay there. It's going to, the market forces are going to try and increase it or decrease it. So what the government has to do is play around with the money supply and adjust the money supply accordingly to make sure that this relationship is, this interest rate is held as constant. So this is the equation for interest rate. And what we are going to do now is we're going to take this equation right here, and we're going to plug in the value of I. And so if we do that, what we get is y equals to 1 minus C1 minus B1 C0 minus C1t plus B0, and here's where we plug in I. So we get B2 times D1 by D2 Y minus B2 by D2 times M by P plus G. So this is just basic algebra. We're just plugging in different values. So if I simplify this further, what I'm going to do is, since we have Y here, I'm going to try and bring this Y outside. So what I am going to get is Y plus, what do I get? B2 d1, d2, 1 minus c1 minus 1 times y equals to 1 by 1 minus c1 minus b1 and whatever else we have inside the bracket. And so if we simplify this further, we are going to add this to y, so this to y. Take it to the other side, we will get d2 1 minus c1 minus b1 divided by d2 1 minus c1 minus b1 plus b2 d1 times what we had here. So 1 by 1 minus c1 minus b1 and what's in the bracket. So this part we can cross off. And so what we end up with is y equals to 1 divided by 1 minus c1 minus b1 plus b2 d1 by d2. And what did we have in the bracket? C0 minus c1t plus b0 minus b2 d2 times m by p plus g. Okay, so in this case, this is our multiplier, and this is here is the autonomous part of the consumption. And so as I've already told you guys, I'm not going to expect you guys to do calculations like this. I mean, at the end of the day, this is just algebra, and this is a macroeconomics course, not algebra. So I'm not really focused about whether you can do all this algebraic stuff, but what might help is that to think about what we have done here is that we're allowing the interest to keep the interest rate fixed. We have introduced this equation. As a result, the equilibrium condition has changed over here. And what it might be interesting is for you guys to think about what the change is, what the changes are, why this change is taking place, and what implications that's going to have for the economy. So I've done the calculations, this entire thing, but now just think about what this means. So let's move on. So part D is draw the diagram. That's not really that challenging. Let's see. Question 3, you see we have the exact same C, I, and Z. It's really no difference here. Part B, 3B is exactly 2C. So why don't you guys try and solve that? Let's do part C. Part C is solve for equilibrium level of investment. Okay. So 3C, what we know is I is equal to B0 plus B1Y minus B2I. It's the equation that's given to us. And what can we do from here? Okay, and what we also know is that I, interest rate, is equal to, how much was it? D1 by D2 times Y minus D2I. So what if we plug this value right here into this value of Y? What we are going to get is B0 plus B1Y minus, and now we bring this in. So B2 D1 by D2Y minus B2 Wait, have I copied this correctly? Right, this is 1 by d2. I've made a mistake here. So 1 by d2 m by p. So what we get is b2 by d2 m by p. Excuse me. And so if we just simplify this a little bit, what we are going to get is b naught plus b1 minus b2 d1 by d2 y minus b2 by d2 m by p. And this is the equilibrium level of investment. And once again, I've done the algebraic calculation. That's not really that interesting. So, I mean, you guys may have similar problems in the assignment for practice, but during the exams, I'm not going to ask you guys to solve something like this. So don't worry about that. But it's, once again, it's interesting to think about this. We started off with assuming that investment was fixed. And so effectively what we had was that investment was fixed. Then we relaxed some assumptions. We wrote down investment is a function of y and I. But once we did that, y was changing. Of course, we were allowing interest output to vary, but we didn't really know much about interest rate. So this was in the second stage. Now what we have done is we have the same condition, but we also know something about I right now. We know that I is d1 by d2 y minus 1 by d2 m by p. So notice that we've gone through 3 stages of how we deal with investment. From it being fixed in chapter 3, I think it was. Then we endogenized it and made it look like as our output was changing, we allowed investment to change. And then in this stage, what we have done is we've allowed both of this to change. Interest rate is changing now as well because we have this question. And as a result, from being a simple fixed parameter, this is what our investment now looks like. We have Y here. We have money supply here. And so you see things have gotten complicating. And so what I'll ask you guys once again to just sit down with this equation and think about what this means. It's easy to see this progression from 1 to 2 to 3, but technically, mathematically, this is what's happening right here. And it's quite instructive to just go through this equation and this equation and just trying to figure out mathematically what is going on. Because even though you won't have to solve problems like this, if you understand these equations, your analysis of other problems are going to be much better. So I'm not doing the analysis for you guys because I want you guys to think about it, and hopefully your understanding improves. So we've done number 2 and 3 from this chapter. The assignment. So we have assignment 3, which is from chapter 5. You guys will have to do number 1, number 5, and number 8. And of course, this is due on lecture 8. All right, so now that's all the 3 assignments that you guys have to do. So from chapter 3, you have to do 1, 6, 8, 9, and 10. From chapter 4, you have to do 1, 4, 5, 9, and 10. And from this chapter, you have to do 1, 5, and 8. All of this is due on lecture 8. So this is also the end of our syllabus for the first quiz. Quiz 1 is also on lecture 8. So that's why I've planned it to, I've structured the course this way so that we've finished the 3 chapters. You've completed the 3 assignments. And so now you're ready to sit for the quiz. So lecture 8 will be the perfect time for us to have the quiz. And after that, we'll move on to medium term analysis.